which are required and the need of our. So we have in this session showcase from our presenters in which they will showcase the transformative innovative solutions their organization have come up with. So I would like to now invite Mayor of Goyang City to first give a few words, and then I'll hand over the mic to Professor Kim. So Mayor of the city. As
I am Donghan Lee, the mayor of Goyang Special City, South Korea. And it's I'm sorry. Mm. It's great to see familiar faces, and nice to meet you all again. Goyang City, along with the UGIH, has been working on pilot project this year. Following our work from last year, understanding GHG emissions in cities, where over 17% of global emissions happen, is challenging. To address this, creating a greenhouse gas inventory is essential. Goyang City partnered with UGIH to analyze local emissions last year. This year, we aim to track emissions moving between countries and cities. Goyang City Research Institute, British Columbia Province, University of British Columbia, and Professor Ki-gon Kim from Seoul National University collaborated on this research. Cities at the end of the consumption chain and need to calculate emissions during the entire uh, life cycle. We hope that our study, even in a small way, has been helpful to Goyang and British Columbia in creating inventory and response plans based on our research. Today, we are here to share the results of the past year. Professor Kigon Kim will present on our behalf. Let's welcome Professor Kim to the stage with a round of applause. Mm, Thank you.
Thank you very much, Mr. Mayor, for introducing me to the audiences. Good morning, ladies and gentlemen. I am very much honored to be here and would like to thank you very much to the UNFCCC, UGIH for inviting me to share a result of our collaborative project between the Korea and Canada, British Columbia. And here we have the search team, the Korean team, and this is British Columbia team. On behalf of the this team, as the mentioned by Mr. Mayor, I will make the result of our collaboration project to report to you. And here we have two members, Professor Mi Jung Park. She's sitting there to help my presentation. And the other member, Dr. Catherine Artican, she's there from the Stanford. And I'm the principal investigator of this particular project, and Professor Carson, who is of University of British Columbia, he is the principal investigator for the Canadian research team. And he cordially asked me to deliver his apology to audiences for his absence. Having said that, let me move on to here table of content. Yesterday, in the opening of UGIH, Honorable Mr. Mayor and also the Deputy Mayor for of the protocol, they pointed out the importance or value of the demand management for climate crisis. At the same time, the GHG accounting system. Also, they pointed out the importance of digitalization and also knowledge sharing. And this morning, the Dr. Masamba theory, he also pointed out the four requirement or element for local policies, which include the sharing, cooperation, innovation, etc. So I hope you will see how our collaborative project will entail or include the point which was made were made by mayors and also which was made by Dr. Manta Theory. Next one, please. Here, the we have the some background of the collaborative project. Actually, the Canadian research team is responsible for production and the transport of the liquefied natural gas. And the Korean team is responsible for the demand side of the natural gas. So there has been very recently a shift from production-based approach or the supply side approach for the consumption or human need-based approach. In dealing with the climate crisis or emergency or disaster, at the same time in dealing with the GHG accounting system. And we selected heat, which is one of essential human need, to illustrate the to LCA, the lifetime life assessment. At the same time, human need-based approach to GHG accounting system. Please forgive me. We are far behind schedule, so I will move as quickly as possible. So with your understanding, in terms of the project, the background, Canadian foreign minister visited the Korea and had an interview, and she said in 1920. 25, Canada will be exporting LNG to Korea and will become one of the biggest export to Korea. Korea actually has invested a huge amount of money the, on in west coast of Canada to exploit the LNG with the Mitsubishi and also Shell. So in from 2025, we will import the LNG from Canada. So production and the transport process will be covered by, has been covered by Canadian research team. This project aims to develop the cycle thinking, errant life cycle thinking based on GHG accounting framework and methodology. At the same time, at the downstream of the project activities, we has focused on the empirical study as the demonstration test to illustrate the need-based approach to GHG accounting. Next one, but to achieve these aims, we have developed an overall framework which you are looking at. It is a model example of the multi-level climate action to meaningfully reduce GHG emissions, which shows the connected component of the climate action, if you like. Next one. Within the broad framework, we developed another framework for tracking emissions over the time LNG. Starting from Canada, the LNG extraction down to the household at Goyang City, the consumption at each household. Next one, please. To deal with the there are several issues. I selected two reasons. First one is there is a significant variability in the emissions across different suppliers and natural gas supply chain. Second issue is that most case studies have been conducted for LNG supply chain from production and delivery to industrial use for power plant without assessing how much the human need have consumed at the building and the household level. So we try to seek new alternative methodology and to revolutionize GHG accounting business. We developed the extended method to calculate not only supply chain, but also consumption and the human need the approach. The transfer from production to utilities, to buildings and tenants, which means the consumers. From now on, I will turn to the outcome of British Columbia, the result on behalf of the University of British Columbia. The PC project focused on the fuel switching effect with natural gas and creating new international carbon trading mechanism, market mechanism with different options of scenarios. The actual export from Canada to Korea will begin in 2050. So in 2025. So they used the scenario approach, not on real world. I hope you understand what I'm trying to say. But for the consumption side, we deal with the real world, with the digital technologies in Goyang City. You will see what I'm talking about later on. The Canadian team generated and assessed 36 export scenarios and conducted GHG accounting to determine the potential emission saving with the beach LNG over conventional fossil fuel, which means coal. So coal versus natural gas. Here, we assume the natural gas is one of clean energy. That's the hypothesis. According to scenario one, the avoided emissions from the 45 to 75 methane can be reduced only to cater for the district heating. PSTEAM is also forming a potential carbon market mechanism, which is shown is here to deal with the TIMO, the ITMO, internationally transferable mitigation, outcomes.
May I request Professor
Yeah.
to brief? In the interest of time, can you be please quick? Can you be brief? In the interest of the time, can you be please brief
Oh,
in
yeah,
your
yeah, yeah.
presentation?
We try to make it short, but originally it was scheduled for 20 minutes, so I will make it shortly. Okay, and then let me move on to the considering your recommendation. Move on to the the Korean case study. This is a project impact of the British Columbia. The I will skip off. And project aim, next one, please. I will move on to now Korean case study at the downstream of the LNG project activities. Here we have some background. Actually, UGIH launched this project. It is the first project of the UGIH initiative on GHG accounting system. This particular project is designed for evidence-based the empirical baseline inventory, which helps for setting science-based GHG reduction target. Particular the project has primarily been designed with digitalized carbon footprinting data and covers that supply and consumption at low level profiles. Next one. Next one. We have the developed two milestones. One covering CO2 emissions from utility. Next one, please. You can see here utilities to shopping center to tenants shown in the figure. The other focused on residential buildings. Next one, please. Next one, please. Residential buildings shown in this particular figure. I think these diagrams are good example of digital innovations in the city level accounting and climate actions for enabling the digital accounting and using the remote control. Next one, please. Here we have some the findings of the LNG consumption in Goyang City. The import of the LNG has increased over the time period in 2021 and 2022 by 1%, but the cost has doubled. Here you can see the major LNG exports to Korea are Qatar, Australia, and USA. And the local heating occupies the big portion of the LNG. Next one, please. Here, another figures tables. I will not go into the details of each figures because he's a bit nervous. I feel, if allow me to say. And now I will here life cycle greenhouse emission in progress. So the starting from LNG intern terminal and to Goyang City, how much energy the attribute to each stage of distribution, and then the energy will be converted the GHG accounting amount of GHG accounting it will be done by end of the this year with the Canadian research team together with the Korean research team. Next one, please. Here are some figures I will skip for. Next one. Please go on, skip. And I hope this material will be on YouTube. Then audiences will hope to pay more attention on it. And here, I will concentrate the more time on the digitalized data set. Here, you see sample example, the view of a data set which has been monitored with the digital devices, including the digital sensors, IoT, and also the cloud server, which keeps the data, and also automatic heat exchange, something like that. Please go on. Please, this is a skip. And then here, the tables shows some information on monthly the consumption of the heat and the GHG accounting, also monthly based the variation using data set, which set up by with the digitalized the system in Korea. And here, product impact include, we hope the Korean case study provide the basic information and data on baseline information inventory, which can be used for baseline scenarios and the GHG reduction target setting at the local level. Next one. We tried to synthesize the result of the Canadian study and the Korean study. This one shows the combination of the lifestyle assessment and consumption in terms of, please stay in a moment, production, transport. That's covered by Canadian team. And also the consumption by first order user in the second order, something like that. Okay, I will, and then we would like to suggest to adopt some kind of protocol for the GHG accounting system. Also, the community driven, next one, please. Community driven. Next one, please. Next one, please. Here, no, but please go back. Please back. Yeah, here, no, please go on. Go forward, please. Yeah, I will spend just 1 minute. This is rather inconvenient. And here, protocol, I will, if I have more time, next time we will talk about the protocol. And then here, this one, please. Here, this is a community-driven system, and to mobilize the grassroots support in preparing PhD accounting system. And then next one, in conclusion, I would like to there's a need of transparent the transfer of the information on GHG accounting system from producers to the consumers. That's what we have concluded. Finally, 1 minute, please. Ladies and gentlemen, I firmly believe that UGIH will be or could be an architect of GHG accounting transformation because of the following two reasons. First, we have to use science and artificial intelligence for filters of the GHG emission account. Second reason would be the tentative result of the humanoid approach to GHG emission accounting may show that consume consumption need-based added GHG consumption would significantly, significantly larger than production-based GHG emissions established using the conventional GHG accounting system, so-called the production-based approach. Therefore, I think it is time to act, to bring more partner cities in this collaborative project. I saw the in this venue the some kind of the phrase. Action inspires the hope on the way on my way to this venue. I saw action inspires hope. So for the PhD accounting system, my expectation also the also action inspires the hope. Thank you very much, ladies and gentlemen.
Thank you, Professor. It was very interesting indeed. So I would like to invite Miss Barbara Dale now to make her presentation. She's from the German Federal Agency for Disruptive Innovation.
Yes, thank you very much. And I also have some slides, but if not, I'm also happy to talk without slides. But if you could pull them up, that would be most wonderful. All right. But first of all, thank you very much. Thank you very much for having us, for including us in this panel. Massive thanks to Masamba and the team, and Sylvia and Alex in the background, and Nitin and so on. Thank you really for including us into this lineup of speakers. So it's my pleasure to briefly introduce Sprint to you, and you may be entirely forgiven if you have never heard of Sprint before. So we are the Federal Agency for Disruptive Innovation in Germany. Next slide, please. And oops, sorry, can I click forward myself? Oh, excellent. So the mission that is behind the agency's work is really to scout, to support, and to develop innovations with breakthrough potential. And in that, we find ourselves very much aligned with the mission that the Innovation Hub is promoting here, to really look at core human needs, really look at problem solving, and opening up this more expanded innovation agenda for human life here on this planet, to live better and more sustainable and more climate friendly lives in the future. And as a player on the innovation scene, we are kind of new. We're not entirely new, but we would say we're new-ish. Founded formally in 2019, and it was really a personal initiative by former Chancellor Angela Merkel, who in 2016 convened these very high-powered innovation dialogues at the Chancellery, to which she invited captains of industry, policy mandarins, research grantees, and really to forge a kind of a new innovation agenda for Germany. Because I think the realization at the time was that as far as innovation funding was concerned, Germany had been perfecting all these mechanisms to really support incremental innovation, but not really focusing on this breakthrough stuff. So this was really the origin of it, and I can obviously expand on that, but probably more over a cup of coffee because I know we're short of time. So what have we been up to since 2019? So first of all, probably to say that we are completely technology agnostic in terms of areas where the innovation really comes from. We also include social innovations in the agenda, but we quite frankly, we do not get very many proposals from that space. So it's still very much, I would say, 99.9% something to do with technology when it comes to breakthroughs. We're sourcing we're sourcing the projects basically through two mechanisms: bottom up and top down. The bottom up process is open anytime, and it's really designed in a way that every man, woman, and child that really thinks that they have an idea how the world can be better in the future should be able to submit an application. So it's not your usual process whereby you have to plow through 26 pages of funding guidelines before you even get to submit your application. But it's really just a catalog of 12 questions that you have to answer, and off it goes. So we reviewed about 1,300 applications. We have selected about 45, so that equivalates to probably about 4 to 5% success rate. We launched challenges, we have funded teams, and we actually also brought one of our challenge teams with us today, which is great. So Hannah, hello. And next year our budget will be about 200 million euros. So where do we really see our niche? Where do we see our space? We focus very much on the very early stage of technology development, not the basic research, because that is taken care of by other entities, but really that heavy lifting that needs to be done when you're trying to bridge the gap between basic research and, let's say, market entry. So that sort of demonstration phase, validation phase, which is very, very hard to fund, because private investors won't go there because it's too risky, it's too early. So this is really where our niche is. We're looking for innovation breakthroughs, and we are also seeing ourselves as really partner to our innovators. I think it's fair to say that we really do not want to be just someone who writes checks, but actually also someone who provides much more comprehensive support, because we know that developing an interesting technology is easy-ish, but to actually make a breakthrough out of it requires much, much more than financing. It requires networks, it requires access, it requires platforms where you really can talk to users, to customers, etc., etc. And of course, we are spending taxpayers' money, so we are acutely aware of that we are custodians of public money. And but we also try to find new and agile ways on how to spend that money. And we have a bit of an internal joke within the agency to say the first disruptive innovation of the Agency for Disruptive Innovation is the Agency for Disruptive Innovation. So we see ourselves as well as innovators in the system of trying to find new mechanisms of actually funding projects fast. So we have a set of challenges as well, challenge-based competitions, and I've thrown a couple of here for you on the wall, really tackling very, very broad themes like long-duration energy storage, circular biomanufacturing, tissue engineering, carbon to value, and we are currently preparing new ones on fully autonomous flight, and then next year about, as well, critical raw materials. So these are themed competitions where a call goes out to the innovation community, not only in Germany actually, but internationally as well, to say, please come forward your ideas. If you have an idea of how to address that challenge, please, we would like to hear from you. And this is probably too detailed, but as I said, we're trying to find new ways of leveraging the amount of public money that can go into a project. And this is maybe something where the last slide that I'm leaving you with is also that we're not only thinking about how to develop technology, but also to develop these sort of pull mechanisms on the market side of things that are really necessary in order to scale those technologies that we are funding at an early stage. So we are very much engaged in debates on how to leverage public sector procurement for innovation, how to work with sort of market shaping mechanisms that allow us in a variety of areas like health, climate tech, and so on to really scale projects. Because really getting project to scale is what matters in this space. And the first sort of trial for us is really spearheading an advanced market commitment for projects that tackle the idea of a penicillin against viruses. So broad spectrum antivirals, because we've just come through a pandemic. And I think we would be grateful if, when the next pandemic comes around, we actually have medication that helps us to bridge the gap until actually vaccines become available. And of course, building these sorts of broad spectrum antivirals is something that big pharma will never fund, especially when it comes to the clinical validation, because they don't know when the next pandemic is going to come, and so they don't know when they're going to earn money. So it's an interesting space, and I just wanted to bring that to your attention. Would love to chat to you afterwards if you can. But now, really, to the two stars of our show, our projects that we brought along, and thank you very much for your attention.
Thank you, Barbara. So our next presenter, Christian, please.
Thank you very much, Barbara. Sorry. So I'm Chris Bogatu. I'm with Oliment. I'm a co-founder of Oliment. And Oliment is one of the projects that Barbara mentioned that we with Sprint want to make really big with German technology commercialized worldwide. So Oliment is about the future of cement. You probably know that the most used substance of human beings is water. Guess what is the second most used substance? Concrete, right? Which is made from cement. And you just look around and you know what I'm talking about in Dubai, right? So um, the cement industry is causing a lot of trouble and is already in a lot of trouble. It's a very heavy polluting industry, causing 8% of global greenhouse gas emissions. That's almost triple from airplanes or boat transport. So that's the macroeconomical view. But if you look at one company, one cement company, their business case is very much challenged with CO2 emission rights that they have to purchase. So that industry as it is today will not survive like that. So the problem is on two sides. Two-thirds of the emissions comes from the chemistry, right? There's calcium carbonate and there's carbon in the raw material where you make cement of. And one-third of the emission comes from the high temperature, the thermal process that you need. So with Oliment, we're using olivine, which is magnesium silicate. There's no C in here. Like I spare you with the chemical details, but you don't see any carbon in that formula, which means there's no carbon getting out if you make cement out of it. And the temperature is only about half the temperature. And the energy that you need to process Oliment is only one third. And it can be completely done electrically with green energy. And by the way, also as a flexible load. So we're adding flexibility in the energy system as well. So the comparison is very drastic 590 kilogram per ton of cement versus zero, right? So that's a real disruptive innovation that Barbara was talking about that Sprint is supporting. Very importantly, this is found worldwide. Olivine is the magnesium silicate is the resource. You can find it everywhere because 70% of the Earth's mantle is made of magnesium silicate. So it's really ubiquitously available. And again, the advantages it's zero carbon, it's low cost because you have lower temperature, only one third of the energy, which is a high contributor of the cost for producing cement. It's highly scalable because it's ubiquitously available. The performance is at least similar and sometimes even better. So, for example, you have a lower pH value, which means you can also use alternative reinforcement material like carbon or glass fiber. The usability is the exact same. So on the construction side, people won't know the difference. It's the same thing. They just use the olivine-based, Oliment-based concrete in the same way. And most importantly, the industry, the cement industry, they have $1,000 billion invested capital. So we better make use of that invested capital to produce Oliment in order to make this all happen, right? So if you compare on these six dimensions, other approaches, so you can reduce the clinker, which is the cement content. You can do artificial intelligence supported measures to make a better mixtures. You can create new binders, but all or you do carbon capturing and or carbon capturing and utilization or storage. But basically, either you increase the cost or you decrease the quality, or it's not ubiquitously available on that scale, right? We all need shelter, one of the core human basic needs, right? So on that scale, it's very difficult. Right? So we've done extensive testing over the last half year with different customers, and basically they test the testimonials are really great. They say it's a real breakthrough with tons of opportunities and applications. It's a realistic alternative. It's very much in the beginning yet, right? So we're starting this whole process, but it's super promising, and we're right now planning the construction of a pre-industrial plant that can produce 300 tons per day of Oliment. And we're going to start next year with the construction. So this is basically where we are, right? If you do these basic heavy industry breakthrough innovations, you start in the lab, then you go to the, let's say, kilogram per day scale. We are right now at the 1 ton per day scale. So it's already somewhat scaled up, but the next step is going to be very important in scaling the technology. This is our team. The inventor, Frank Bellman, and his father are basically they've been working on this for the last 4 years, and I'm joining the team now as co-founder. And we have on our board Gerd Kromme, who has been the chairman of the board of Siemens and was the CEO of ThyssenKrupp. So he can be very instrumental for us to really scale the technology worldwide. So thank you very much. Get in touch, please. And looking forward to your comments.
Thank you, Chris. Now I would like to invite our next speaker, Hannah. You have the floor.
Very, very, very exciting.
Indeed. Thank you for that. And I also have some slides. Shall I just click? Oh yeah, if you could please pull up the slides for carboculture. Thank you so much. So my name is Hanna and I'm head of carbon markets and policy at carboculture. So we think that you need systemic solutions for systemic problems, and this is how we came up with doing what we do, and which creates the reason and the mission for everything that we do. So, what's the problem? It's the largest in the world, climate change. Now we have a climate emergency. We're headed to a 3-degree global warming, and it's not just about having too much carbon in the atmosphere at the moment. We still see too much carbon being emitted into the atmosphere on a daily basis, and increasingly so. Furthermore, there's all kinds of other challenges that we're also discussing here at COP for these 2 weeks, such as soil health, food security, among others. So we decided to focus on the problem of carbon in addition to what we can do as co-benefits in addition to removing carbon. So for us, we've taken the mandate of the IPCC very seriously to say that in addition to drastic emissions reductions of 90%, we are going to need some carbon removal. So man-made carbon removal where in addition to nature-based sinks, we managed to build technological carbon sinks and also enhance nature's own carbon sequestration. So our solution is biochar, which could cater up to half of all the carbon removal needed. And I highlight not half of the emissions today, half of the 10% after drastic emissions reductions. So who are we? How are we equipped to solve this problem? Well, we're Carboculture. We're a Finnish Nordic project developer with our own proprietary technology, the patented technology for biochar carbon removal. We raised 25 million in equity and also 5 million euros in grants. We're very grateful for almost 3 million of them for have come from Sprint that was showcased earlier today. We were founded in 2017, so we are, when it comes to carbon removal, already quite an old chap, but of course there have been many first runners before us. And at the moment, we're running an R3 industrial pilot in Finland in the greater Helsinki region with an operational capacity of 3,000 tons of CO2 per year. It's not much compared to the 10 gigatons that the IPCC has been talking about, which is 10 billion tons of CO2 per year, but it's a start and it's already one of the largest carbon removal facilities in Europe. I almost want to say sorry to say that it's only 3,000, but we have to start somewhere, right? Our CO2 removal is accredited by Puro Earth, which is a NASDAQ-owned carbon accreditation platform. We take MRV and this carbon accreditation very seriously, and we're very happy to have this partner on our journey. We have plans to start our first commercial facility and open it in 2025, sorry. We have 25 full-time employees who are working very hard every day to make this a reality. As I mentioned, Sprint, we also work with other industry partners. We are part of the world's largest portfolio of diversified carbon removal run by South Pole. It's a facility called the Next Gen facility with other partners such as Swiss Re, UPS, Mitsubishi, among others. In addition to that, we're working with the European Investment Bank and to enhance our fundraising. And also, we've been funded by True Ventures and Gen Zero for our Series A that we just closed last week. We've also signed purchase agreements with notable companies such as Rothschild and Co. And Zendesk. So how does biochar work? I mean, I talked about this huge problem and I talked about this maybe a bit vague solution thus far, biochar. How does it actually store carbon and for how long? So we store carbon for over a millennia. And how do we do it? Well, we think that Mother Nature, in the billions of years of existence, has figured out the best and most efficient way to draw down carbon, which is photosynthesis. I believe I don't have to explain anyone here what photosynthesis is, but just to recap, plants harness and sequester CO2 from air, which they then store temporarily. For us, this is not long enough, though. We need to ensure that the carbon that these plants sequester could be stored for longer from the atmosphere. I mean, in the ideal case, we wouldn't need to do anything. There's a natural carbon cycle that works. However, we have already dug up so much fossil energy from the ground that we need to do something. We can't. The natural carbon cycle can't solve itself anymore. So we take that waste biomass and we stabilize it. We pyrolyze it, so we take it to a very high temperature for a short amount of time, producing renewable energy, carbon removal, and biochar at the same time. Therefore, solving the problem not only of having too much carbon in the atmosphere, but also lowering the amount of carbon that is being emitted and also healing depleted soils. And how we do that is our carbolysis reactor. From that, we have three revenue streams, which are the carbon credits, biochar, and energy, which we want to utilize to actually create bankable projects where we can create wealth and make the green transition a reality with solid innovations. Carbolysis is our patented technology. We're very proud of it. We have a very high net carbon removal capacity. For every ton of biochar, we generate over 3 tons of CO2 net removal. There's no external energy need. In fact, the process is exothermic. We produce energy. So we can either heat water for district heating networks or produce electricity from our syngas. We're the proprietary technology owner, so we have full control over the design, fulfillment, and schedule, and therefore also have less maintenance cost thanks to the clean outputs. And this is biochar, the star of the show. Sorry that I'm only showing it so late, but I mean, it really makes sense, right? You know, when we're talking about technological carbon removal and kind of the natural carbon cycle, and we think about the fossil energy that we've dug from the ground, what do we think? We think of oil, we think of gas, we think of coal, and these are all the ways that the technological carbon removal solutions are trying to put those things back to where they belong. I mean, carbon itself is not a fifth most abundant element in the world. It's just in the wrong place. So now what we're working on together with the entire carbon removal industry is putting it back where it belongs. With biochar, we can store it safely in the soils. Of course, we do it. We can store it safely in the soils, where we can also have the co-benefits of soil health. For that, we can achieve a high permanence, negative energy use, and cheap and safe storage. when you're creating biochar, if I just saw from the previous slide, you don't need to transport in a pipeline. You don't need to store it in a geological storage. It's there. The technology exists today, and we're very excited to see how we can work together with both companies and governments to make the net zero goal a reality. Thank you very much.
Thank you, ma'am. Now, I would like to invite our last speaker for this session, Mr. Krishna Prasad Chigurupati from Granules India, to make his presentation.
Maybe I'll just take the clicker. Oh, I thought this was I should remove this. Oh, okay, it works. Okay, good. Uh, Good afternoon, ladies and gentlemen. I represent a company called Granules India, and we make generic medicines all the way from some of the chemicals to APIs and to formulations, and we market it across the world. Today's subject is decarbonizing the pharmaceutical industry. And since we are running short of time, I would like to skip a few slides and go straight to the point. However, the first slide is I always start my presentations on sustainability with the latest quote by the United Nations Secretary General. And if you're wondering what these two creatures are on the right side, that's me and my wife. We have run marathons many times in Antarctica and the Arctic, visited the poles, and over 15 years, we have seen the changes happening in these areas. So I echo the thoughts of the Secretary General, and I'm deeply concerned and agitated about what's happening there. I'll skip these slides. It's all pledges made. And of course, we all know that even if all the pledges are maintained, we're likely to head towards 2.1 degrees C warming instead of the 1.5. This is very, very disturbing, and this could be devastating. Massive action is needed, and it's needed now. As the world focuses mostly on renewable energy and sustainable mobility, the time has come to decarbonize the industrial sector. As Chris has mentioned, cement is one big sector, and I'm glad people are working on it and finding solutions. And finally, let me talk about pharmaceuticals, which is part of the chemical sector. Pharmaceuticals is supposed to be in the noble business of healing lives. But are we doing enough? Are we also healing the planet? I think we need to do more. 260 million tons of CO2 equivalent was generated by this industry in 2022 and is growing at the rate of 15%. Most of the emissions are in scope 3, which is a supply chain. The time has come to decarbonize the supply chain now. And we plan to use green technology to do this. Decarbonization is mostly on three pillars. One is green molecules. As nations and the world is looking at hydrogen by electrolysis and ammonia as a source of energy for increasing mobility, there is a vast scope for creating other chemicals from these, which could also be used as building blocks for making intermediates and KSMs for pharmaceuticals. And also, uh, even though we have green chemicals, we need to use them wisely. Biocatalysis, organocatalysis, flow chemistry are very important. We are working on those. And finally, in formulation manufacturing, solvent usage, polymer usage are very carbon intensive. And of course, plastic is another concern. At Granules, we are embracing green science and we are committed to net zero by 2050. Now, let me come back to the first pillar, the green molecules. Hydrogen is produced by electrolysis of water, and of course, from air, we get nitrogen and make ammonia, and then methanol. Methanol, of course, needs carbon dioxide, and carbon dioxide can be from captured carbon from industries burning biomass, such as sugar industries. Our new venture, C0, has been set up to produce green molecules near with near zero carbon footprint using 24 by 7 renewable energy and also built-in circularity. We are partnering with two companies in India, Greenco and AM Green. Greenco is a huge generator of carbon-free renewable energy, and is and they're working on a gigawatt capacity battery based on pumped hydro. This site is getting ready in the next few quarters, and AM Green will be using 24 by 7 carbon free energy from this site and producing green hydrogen, green ammonia, green methanol, and green urea. Here I have to mention that green urea can really make a big difference to the agriculture industry too and decarbonize part of it. From granules and AM Green together will produce hydrochloric acid, green nitric acid, caustic, PNCB, PAP, and many more chemicals. Just to demonstrate the uh, value chain of to give you an example of the value chain, I've chosen two products in the pharmaceutical sector which are which have the largest usage in the world. One is paracetamol and the other is metformin. Paracetamol is used for pain management, and if you see this organogram, we start with benzene, and with benzene we chlorinate it with green chlorine. We use green nitric acid to make nitrochlorobenzene. We end up with ONCB, PNCB. ONCB goes for green dyes and chemicals. PNCB is further hydrolyzed with caustic, made at the same site, and then hydrogenated with hydrogen and neutralized with HCl, and we get PAP, one raw material for paracetamol. On the other side, we have CO2. CO2 along with hydrogen becomes CO and water. CO and methanol mixed together becomes acetic acid. And with acetic acid and PAP, we can make paracetamol. Now comes metformin. DCDA is one of the main raw materials, which is similar to cement. It starts with calcium carbonate. In this process, the world today uses highly energy intensive processes for making DCDA, and also the entire manufacturing is just controlled by one country. We have innovated a simple process where we use urea and calcium oxide. In the first stage, where both are heated together in the kiln, ammonia and CO2 are generated. CO2 goes into downstream processing for DCDA, and ammonia goes into the next raw material, DMA-HCl. A byproduct of DCDA is calcium carbonate. Calcium carbonate is again heated to become calcium oxide and hydrogen, and CO2. CO2 again goes for use of making in methanol. On the other side, ammonia, HCl, and methanol combined together. Ammonia from the first stage of making DCDA is used here for DMA HCl. Ammonia, HCl, and methanol make DMA HCl. Both combined together become metformin. If you see, everything is circular here, and some of the material that's emitted here as byproduct goes into paracetamol too. All the raw materials here, except benzene and calcium oxide, are made at the same site with renewable carbon free energy as the key raw material. It's just water and air. This also avoids transportation, again saving in the carbon footprint. So these two products are examples of how we could make pharmaceuticals green. And in the previous slide here, benzene is the only material that comes in from outside. So far, research is still going on in making green benzene from biomass, but we are still a little distance away from that. And once we have benzene as green, the entire footprint of paracetamol is going to be zero. Metformin is already zero, almost close to zero, as calcium oxide has very little carbon footprint. And then, of course, having green molecules is one, starting from that, but also we need to use them economically. And some of the ways of doing that is biocatalysis and flow technology. Even though these two technologies are widely used in the chemical industry, unfortunately, they have not been uh, used in the pharmaceuticals. We expect to popularize this too. And finally, formulation manufacturing. Though plastic is a very big concern, people are working on different solutions. We are working on elimination of solvents and polymers, and substituting them with plant-based excipients. So this is Granule's new approach to pharmaceutical manufacturing with maximum efficiency and minimum carbon. This whole exercise is getting us close to our purpose of healing lives responsibly through pioneering green science. Thank you. Nathan, I hope I kept it short and
Thank you.
quick.
Thank you very much. You were super quick. So nice of you. So with this, we come to the end of this session. Thanks to all of our distinguished presenters. Very nice and interesting stories we have heard from you. Thank you very much. Okay, so we'll start the next session maybe just in 2 minutes. You have some plan. So
I'm Sola.
I'm sorry, it's difficult to pronounce your name. Is hers?
Well, my name is Solveig.
Solveig. Solveig is okay.
But everyone calls me Sola.
Sola. Okay.
We had a couple of delays on our
Yeah.
part.
Yeah.
It's absolutely fine. I'm just wondering.
Will you be able to finish by 1? Because we have a high level session coming up 2 o'clock, and it's getting late because of
At 2 o'clock, will be.
yeah, because we have another one after yours. We have another one. So if you can be like finished by, let's say, 1:05 ish.
I can try that. Can try. But can we then be quite quick to set up so that we
Just you can ask your speaker. Sorry, we have the soft signal, then to just the next back to back.
down for the forward. Almost. Yeah. Warm or cold. Next week with
You need handheld or you need?
No, I'm all good. What? How many mics do we have?
We have like handhelds. Are you looking at? We have three, I think. We have three handhelds, right? Two. Okay, so
Yeah.
we have two. Yeah.
And we can I can all of that.
Okay.
Yeah, that's inside of you. And
You
it's
can
fine
use
if we
this.
help between at least the people and that's fine. Don't sit on. I would try this.
Okay. This is the second one, right? This is the second one.
Yeah, that's fine. Are you okay with how to put it on?
Yeah,